Hey, thanks for joining me today. We're going to talk about multiplying and dividing fractions. And we start with multiplying and dividing fractions rather than adding and subtracting because this is the easy one. So multiplying and dividing fractions is easy. Just remember that. It's easy. Adding and subtracting is hard. I don't know if that's good or not, but that's one of the ways that I use to remind myself how to do multiplication and division. Right? Multiplication and division is easy. It's just one little thing. Adding and subtracting is hard. You've got to do some hard preparatory work before you can do that. Okay, let's get down to it. The rule for multiplying and dividing fractions goes like this. It's really simple. A over B times C over D equals AC over BD. What on earth does that mean? It just means that when you multiply fractions, you multiply the numerators together and you multiply the denominators together. That's it. That's all you have to do. So when we have a problem like this, 5/8 times negative 1/3, we multiply the numerators together. 5 times 1 is 5. And 8 times 3 is 24. And then, of course, don't forget this was a positive number times a negative number, so the answer is negative. And we're done. It's as easy as that. Now we have to remember all those rules about multiplying positives and negatives together. So for example, and I would normally, when doing this, I would normally identify, is the answer going to be positive or negative? When I'm doing the multiplication, I always look and see, is my answer going to be positive or negative before I do anything else? So I would have done, normally I would write the negative sign first. But other than that, that's it. You multiply the tops together, multiply the bottoms together, that's it. Now, we have a whole bunch of examples to go through because, of course, there's going to be more to it than that. But the good news is that the more to it than that is primarily going to be easy. It's not going to be hard, it's going to be easy. Let's do an example where we have an exponent. So we have a fraction, negative 2/3, raised to a power, the third power. What does that mean? Well, we have to remember that powers mean just taking the number, negative 2/3, and multiplying it by itself, negative 2/3, that many times. And it was a third power, so we're going to do 3 negative 2/3. And we're going to multiply all of them together. Now, we could say that the answer is just negative 2 cubed over 3 cubed, which is absolutely true. So we can kind of distribute the power here in that way if you like that. But I'm just as happy to write out negative 2/3 times negative 2/3 times negative 2/3. And I notice that I have a negative times a negative times a negative. That's 3 negatives, so the answer is going to be negative. And then 2 times 2 times 2, or 2 to the third power, is 8. And 3 times 3 times 3 is 27. And there we have it. All right, so multiplying fractions using powers is easy. Now, let's get into the tricky stuff. It's not really tricky, but this is what I want to show you here is what you should do to make life easier for you. Okay, so I said we're just going to multiply the tops together, 5 times 64, and the bottoms together, 32 times 100, and we're going to get this ugly, let's see, this is 320y over 32,000. Actually, that might actually be pretty easy to simplify if you're thinking about it. But here's the deal. Once you do that multiplication, you get a big number here and a big number here. The next step, or the last step, is going to be to reduce the fraction. So we're if we think about it, the old way, we were going to divide the top by some number and divide the bottom by some number. And we had to be clever about what the numbers are and what number can go into each of those. Or my other method, remember, was to take each number and we were going to factor them out. And this is something times something times something times something. And then cross off the factors that are the same. Okay? Well, we're going to use that method, but instead of doing the multiplication first, I'm going to do the factoring first. So I'm going to say, well, instead of doing 5 times 64, well, I already know 5 is a prime factor, and then 64 is 2 times 32, and 32 is 2 times 16, and 16 is 2 times 8, and 8 is 2 times 4, and 4 is 2 times 2. So there are all the factors of the numerator parts. Oh, don't forget the y. And then the denominator, well, we have 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. And then 100, which is 2 times 50, which is 5 times 10, which is 2 times 5. So I factored out the numerator and the denominator, and then I can start crossing off the factors that are the same, just like I did when I was reducing fractions. So this is like reducing the fractions before you do the multiplication. So I just wrote out all the prime factors of both numerators and both denominators, and then I crossed off the common factors, and what's left over on top is a y, and on the bottom is 2 times 5, which is 10. So my final answer is y over 10. Okay, now either method works, but I'm going to suggest that this method, this factoring method, is a surer and a quicker method, even though sometimes it might seem like it's a little bit longer. This method will be more useful throughout algebra as you move forward, so this is the method I want you to practice. Let's do it a few more times. So we have a over b cubed times b over a cubed. Well, a times b is just a times b, and b cubed is b times b times b, and a cubed is a times a times a. And looky there. We have an a and an a and a b and a b. And we're left with, oh, remember what we do when there's nothing left on top? Well, remember, this is just times 1. 1 is always a factor, so we'll just leave 1, because we're technically dividing the top, the numerator, by a and b, and we're left with 1. And we divide the bottom by a and b, and we're left with 2 a's multiplied together, a squared, and 2 b's multiplied together, that's b squared, and there's our answer. Okay, are you ready for the last trick? The last trick is division. And division is only very, very slightly more difficult than multiplication because there's an extra step. You remember, because you've done this before, that division of fractions is the same as multiplication by the reciprocal. So instead of saying 9 halves divided by 16 fifths, we say 9 halves, the first number doesn't change, times, and we're going to change it to times 15 over 16. It's really, really important to recognize that these two things are the same thing. Divide by 16 fifteenths times 15 sixteenths. Okay, that's a tongue twister. So divided by 16 over 15 is the same as times 15 over 16. They're the same thing. And we don't really know how to do division, but we do know how to do multiplication, so we're going to do the multiplication version of this. I'm just going to write out the factors. 9 is 3 times 3. 15 is 3 times 5. 2 times 16 is 2 times 2 times 2 times 2. Okay, now, why did I do that? Notice that there's nothing that can be canceled here. And that's okay. I factored them all out. I observed that there's no factors that are the same, and then I'm just going to multiply them all back together again because there's nothing I can do. I'm just going to multiply them together, and that's the answer. So let's see, 9 times 15 is 135, I think. And 2 times 16 is 32. Notice that one thing I'm not doing is I'm not changing this to a mixed number. I'm not asking how many times does 32 go into 135 and then dividing and coming up with a whole number part and a fraction part. We're done with that. We're not going to do, well, we might do that. We might look at that again, but we don't want mixed numbers when we do algebra. So we're going to leave that behind. Okay, 9z over 20. A couple more examples here. Divided by 6/25 is the same as times 25/6. That's 3 times 3 times z. Be real careful with your z. Make sure you can see what it is. Times, oops, I meant to say 25 is 5 times 5. And 20 is 5 times 4, which is 2 times 2, and 6 is 2 times 3. So there I've factored everything out, and now I'm going to cross off the bits that are the same. And then I'm going to multiply it all back together again. 3 times 3 times 5 is 45. And then the z. 2 times 2 times 2 times 3 is 24. And you can see here, just like in the last problem, we said we don't want mixed numbers, so we're not going to do mixed numbers. But mixed numbers wouldn't make any sense at all with 45z over 24. How many 24s are in z? We have no way of knowing that. So it would make no sense to write this in mixed number form, and so we'll dispense with that because in algebra it is better not to. All right, not sure where this problem came from. A little easy one at the end here, but notice we have a negative and a positive, so the answer is negative. We multiply the tops together, and then we multiply the bottoms together. And that is how easy, I think this is the original problem from the beginning, this is how easy multiplication of fractions is. Thank you very much for watching.